Thank you, everyone. Good afternoon. I don't know about tying everything together, Sasha, but I'll do my best here, guys, to give you a little bit of an update. Really, I'm just going to talk more about kind of some of the trends and activities we see going on in the industry today, and kind of what's happening out there with utilities and with our customers. So I have a lot of slides here, guys. I'm kind of a geek's geek. We talked about the geeks earlier, a geek's geek. But I'm going to talk a little bit about the different prognosis. But did we lose the screen? Oh. Okay. Well, now I'm not going forward. Did we lose our controllers? There we go. Thank you, guys. So overview, I'm going to just give you a very brief overview of Quanta technology, just to inform you guys a little bit about that. I'm going to talk about industry trends, what we see going on in the industry, and then really I'm just going to talk about some data analytics applications. So at Quanta Technology, my team, we're running a fair amount of these analytics projects. Some of these are from other teams at Quanta Technology, but I can at least give you a flavor for some of the things kind of going on in the industry and what we're working on, and then of course any discussion or questions at the end. So Quanta Technology. Our parent number is Quanta Services. So I think most of you guys in the utility space are familiar with Quanta Services. Very large, the largest EPC company in North America. And again, I'm not going to spend too much time here with this other than to say they are our parent company. So here's just a very good eye chart on the number of different companies tied into Quanta Services. So you can see there. So Quanta Technology is headquartered out of Raleigh, North Carolina. We're the consulting group for Quanta Services. So we're about 400 employees, you can see. We deal a lot in patents, papers, studies, other things, roadmaps, working with utilities. And again, you can kind of see our expertise here and some of the things we deal with. And again, these are in the slides, so I'm not going to spend too much time here, guys, just for the sake of the meeting. What's a little interesting with Quanta Technology is it is really a technology-driven company, right? So we're not management consultants. We do a little bit of traditional engineering companies, but we don't do like the detailed drawings. A lot of the Quanta Services companies do that type of work. We're kind of in between. And so we do lots and lots of work with the utilities kind of in that middle space. And you can see here kind of the why. We really are independent. We have a unique business, I think, and technical expertise with software and hardware solutions, testing, commissioning, doing some really innovative things there. So that's just a very brief introduction kind of to where I'm coming from. And in the introduction, Satya mentioned my background. For me, I worked in protection and control for a number of years. My PhD was in power system protection. So I did that for a while. And when I graduated school, I went to work. That's when numerical relays were coming out. And I did tons of patents in the numerical relay space. And then I wound up going over to the meter division in ABB. And all my protection friends were like, for gosh sakes, don't go to meters, stay with protection. And that's when we started talking about two-way communication with meters, right? So we started working on that for a while. And actually the phrase AMI came out of the ABB Raleigh organization. Ron Via came up with that name, not me. Ron came up with that in the marketing team. The only reason I know is because I wanted to copyright it. So luckily, trademark. So luckily the marketing guys talked me out of it. But so now, I've been in the consulting now for about 10 years at Quanta Technology, working with the different utilities. And really, it's a lot of fun to work with the utility customers. They're generally, everyone it's a good group of people, and they have very good technical problems that need solving. And that's really all you can ask for. So what are some of the trends we see in the industry today? So I put significant load growth. We were talking at lunch a little bit about how kind of things have changed, right? Remember a few years ago, we were talking about we may not need transmission and loads going down, and what are we going to do? And now it's just the opposite. We need more transmission and loads going up. So there you have the data centers. We were talking there a little bit about that. You know, I think that's still underestimated, what that's going to do to the system. That's my opinion. Electrification, particularly fleet electrification, is a big issue, a big trend. You know, the frequency and magnitude of major weather events. I've had this point up here for the past few years, bless you, up here for the last few years. And so, unfortunately, guys, we have had this terrible situation in North Carolina. You know, we do a lot working with the utilities on the West Coast for wildfire study, but I think we're going to see, unfortunately, you know, more of that also. And clean energy mandates. And so the clean energy mandates are really driving us. It's going to really transform the grid in the next 10 years. I think it's really, I think that's one of the key things, what people don't generally talk about. We talk about what we know, the kind of the trend and where we're going, but there's a whole lot we don't know, right? So how is that going to impact the grid? How's the grid's going to operate? Which problems are your customers going to see? Which problems on transmission are you going to see? How do you have data? How do you solve those problems when we don't even know all the problems yet, right? So it's a very big issue, I think, is going to be coming up in the future as we go forward. The AI machine learning, you know, trends in utilities, these are just a few of the things, you know, up here. The automated report generation. You know, when I first came to Quanta Technology, we worked on a study with a utility that came to us. We'd already started looking because of PRC 27. It's a requirement. You know, you have to review the protection on your transmission periodically. But we had actually National Grid Saudi Arabia came to us, and they said, we want you to review our transmission line settings. And we said, okay, we can do that. How many lines, transmission lines? So they said, we have 2,000 transmission lines. Okay, so 2,000. Normally for a protection coordination study, you run 10, 12 scenarios. So we said, well, what if we automate everything? What if we set it up? So we wound up running 500 scenarios per transmission line. We ran 1 million fault case scenarios, and we automated all that process, and we put in all the logic to drive it and know what to analyze. It was an amazing experience. That's more on the data management automation, and that's kind of where we started, coming in, really working with utilities to automate things and do them faster and more precise. No protection engineer has ever ran 500 scenarios to check its settings. I mean, in every utility you go through, you would find something there that was previously missed in a thing. So, but I see that, you know, the report generation, the quality control, those types of things obviously will continue. Generation and load forecasting, the data centers, the load growth, we're already seeing that, right? We're seeing that with customers. People are talking, coming in, you know, where do we see? Where do you think this is going to go? Where are we going there? And obviously the load forecasting itself, right? Situational awareness. This is kind of back to my earlier point of, you know, what do we not know? There are certain things we know. So if you know something, it's easy to plan for, it's easy to track, it's easy to see. What do you do when you don't know, right? And so there's some things you can monitor today, but one thing that's very important to remember in the utility space, if you're thinking you're going to be somewhere in 10 years, that's not a lot of time in utility, right? We've all worked in utilities. If you're going to install something, rotate something, upgrade something, you're going out to brownfields, you're going to do certain things in the field, 10 years is not a long time to do it. So, but we see that. And so you see all of this capital projects going on in the utility space today. You know, so there's a lot of things going on there and a lot of things we can do to improve situational awareness. So what are some of the projects that we're working on today? Someone asked earlier, you know, what were the inputs for the grid edge devices? I love that question. So, you know, there's a lot of things going on here in the field today. The digital substation, the IEC 61850 base substation, it's a big area. I've been talking about that since my ABB days. And I can tell you guys, I've seen more activity in the last year than I've seen in my career in the 61850 space. So it's the volume. 61850 is driven by volume. But once you move to 61850 and you really are going to a digital substation, there's so much more you can do on the analytics side, right? That doesn't happen overnight because you've got to roll out your 61850 and you've got to get enough critical mass to do that, right? But if you plan it, it can happen. So 61850 is definitely one of the inputs. You know, the field sensors, there's these smart FCIs out. I don't know if you guys are familiar with those. Those are pretty neat technologies. Smart meters, always. Smart meters are just an amazing thing. I think with the AMI 1.0, you know, when we first launched AMI, the big issue was how do we interface with IT and how do we get them tied in the system? And there's just tons of discussion and effort around that. That's all pretty much worked out now. Everyone's done that. AMI 2.0 is really the next step of where I think we would have liked to have been with 1.0. And it's just as different, right? So the things you can do in the meter today have nothing to do with the meter department, right? And that's one of the interesting things with analytics, the other stuff, it's all of these cross area knowledge you really have to pull together to try to figure out how to leverage this. If you go use your AMI 1.0 spec for your AMI 2.0 system, you're going to get a 1.0 system, right? So, and all of these are reaching end of life, all of these early AMI systems. You can see that moving in the space. PQ meters, SCADA data, GIS data, all this has been around for quite a while. You guys were talking about the imagery, LiDAR in particular. I think with the drones, there's tremendous opportunity there on the inspections and the other things. So the output, there's just lots of things you can do once you put this type of infrastructure in place. One, like fault location, you know, particularly on transmission, you can narrow it down to the tower. The event analysis, protection, you just look for where people spend their time. Protection engineers spend a lot of their time doing event analysis when really there's, you know, 90% of that could be automated. So there's a lot of different things you can do here in terms in the space and what you monitor and how you go forward. Grid situational awareness, you know, guys, I've seen a couple of utilities really focusing on this because they know that there are going to be issues on the grid they haven't seen before. And there's one case we did a paper with a utility, but they had done this earlier, but they were talking about a customer had a flicker issue, right? And it turns out that the flicker issue was caused by two large IBRs, right? An interaction between the controls. Without monitoring on the transmission grid, they never would have been able to figure that out. So even when the customer notified them, they had to go dig through and look for it, right? That took a lot of planning. That took a lot of expertise. They had a great system in place. They set up to figure out to go through and analyze that. So these are just some of the other things you see coming up. Asset monitoring, asset management, obviously is a tremendous area that could benefit from communications to grid edge devices. So another large area there. So here's just a few of the projects that we've been working on. This one we actually completed. It was analyzing PMU data. Is everyone here familiar with PMU when I say PMU data? GPS-based synchrophasers and GPS timestamp synchrophasers on the power system. So this was actually a DOE project that we worked with, with the DOE, and we went through. And so this was a project really to look at kind of how you can analyze terabytes of PMU data. So the problem with PMU data is not having the data, it's knowing when to go look at the data, right? So that's the problem we were focused on in this project. And we did a lot of things to speed up the processing and looking at the data and what you can do. We went through and came up with this new algorithm for event detection to kind of highlight where you need to go look, what you need to see. So this is a new technique we came up with, and we're actually looking to leverage this in a subsequent project that we're working on. And so that's an algorithm we came up with. We're in the process of patenting that and going through. Accurate fault location. This is a project we did with PG&E. We've been working on for quite a while now on the analytics front. This is kind of our first project we got analyzing data from the transmission substation. And so what you do is you can extract information from the IEDs in the substation and pull that back, right? And you can figure out, you can see the graph there where you Oh, I lost the image. The graphic here where you're showing you can kind of map to the tower, the nearest tower for the fault location. So it's a great thing. It takes in different types of data, runs different types of algorithms, tries to give you the option of the best algorithm and the location. And which algorithm you pick is driven by kind of data sources available and other things like that. So this is a project we've been working on. We're still working on with these guys. Actually, we're doing some additional things looking there. Oh. Nope, I lost my go forward. Okay, here we go. So here's another project, GOAT, the GOAT project, as I refer to it, right? So this project, actually, we're just getting ready to start. We should kick it off this month. This is a project to look at interactive dashboard for kind of looking at the health of the system. And this is a little bit, I think, on the cutting edge because you're looking with system operators and how you would present this type of information. But we're working with, you can see here, the group of utilities, the national lab. We put this project together. So the idea really here is to pull in PMU data from across the transmission grid, look at that, and try to help figure out more in real time the status of the grid. So there's a lot of details here, but you can see there. But that's the idea. And so this is kind of focused on the transmission grid and really improving the situational awareness on the transmission grid. So another project switching over to distribution we worked on with customers. We did some cluster analysis for basically for voltage variations across the distribution grid, trying to identify if it's an individual case or a systemic case, and work with customers to go through and map that out. That's something we've done in the past. This was done with 1.0, AMI 1.0 data, right? And again, I would expect a lot of improvements with what we can do there with the 2.0 data. Another package we're working on with utilities, using the AMI data to do some basic things here, service transformer, asset management, outage reliability metrics, grid modeling, power quality analysis, anomaly detection, meter health manage. Again, this is really kind of the first step to leverage the 2.0 functionality in the system. And I think this is going to be a very large area as we go forward, right? So the trick with the 2.0 meters is to figure out what you want to do with the 2.0 meters. They have a lot of power, a lot of processing power, a lot of capability, but how do you leverage that, right? How do you tie that into your processes?
David?
Yeah.
I want to take a second to define what's the difference between AMI 1.0 and 2.0.
Well, 1.0 I designed, so it's old. 1.0 we came out with around in 2000, and really, you know, there were four major players at the time, but in essence, everyone's system was really basically the same, right? It was very focused on the energy usage and the interval data and some instrumentation data and pulling that back, and that was a very standard thing we did. It was a great project. I think it really pushed the industry forward. It's the first time we've ever had sensors across our distribution grid. And that's what I kind of call the Gen 1. The AMI Gen 2 has a slightly different focus in that really the meter itself they put a lot more horsepower in the meter, right? So for example, one thing you can do with some of the 2.0 meters, you can pull back sub-cycle data. And we could never do that before in the 1.0, right? Even with the chipset, it wouldn't support it. So now you can pull back waveforms. There's certain things in there. Most of the guys have things like phase detection in the 2.0 meters, which is really important. You know, distribution forever is operated on rules of thumbs and averages, right? Yeah, yeah. I feel like I'm at church. Amen. So, but the rules of thumb and averages. And so what things like the phase detection and some of the other smarts are going to allow you to do is get rid of those rules of thumbs and averages. You'll be able to improve your load models. You'll be able to improve your grid models. And so you can improve your forecasting. You can improve your load balancing. There's a lot of things that come together with 2.0. I think we barely scratched the surface there with what we're going to be able to do. You know, the old systems like the ABB system, when they used to do state estimation on distribution, they had SCADA at the substation, and then they allocated the load by the transformer rating down all the feeders. You know, it worked, right? But nobody knew if it were correct, right? And a lot is true with the AMI analytics today. On average, it's true, right? So because you take the SCADA at the head end and you use the load data and you balance it and you say, okay, it looks correct. And it is on average, right? Engineers, we hate averages, right? We want to know the status of what's going on because it's the individual feeders or where you're installing a renewable site. Those are the things that are really important to know that specific circuit and what's going on. So I think we're going to get a lot better at how we do that going forward in the future. Distribution system resiliency. So someone, you know, we're talking about extreme weather events. You know, how do we optimize that and look at that and kind of figure out more than the reliability, more of a resilience approach, right? How do you harden the system? Where do you want to place sectionalizers, reclosers, and other things, and kind of automate that process? You're always looking for some sort of matrix with some sort of weighting factor, right? So the utility can go through and figure out, okay, if I'm going to prioritize for this goal, what's the different features and how do I prioritize and how do I do that? So we've been doing quite a bit of work in that area. Again, the recloser placement, you can see here, we've been going through and automating a lot of that, pulling it together and even suggesting sites for tie-ins to improve resiliency, reliability, those types of things. Again, a lot of analytics to improve the process and kind of go beyond what we've done today. Wildfire risk analytics. This is probably one of the widest topics I've seen in quite a while. You know, for my protection background, there's a lot of things to do in protection related to wildfire analytics, but you also have weather analysis. You know, you have, there's a ton of variables here you need to look at. So the wildfire risk exposure, identification, benchmarking, everyone now is being asked, because you would think most utilities are getting the question from people, what is your wildfire plan? What is your mitigation plan? Well, no one's really come up with a wildfire plan before, right? That was kind of a West Coast issue. West Coast has done a lot on that, but now you see that moving across. You know, a lot more people are looking at that and what do you do and how do you try to mitigate that? One thing we did, this was a project we did with San Diego, and this is actually more of a control than analytics. But one problem we tried to solve with these guys early on, we were looking and saying, well, what if your distribution conductor is broken and falls to the ground, it arcs? Of course, that could obviously start a fire, right? So we said, well, what could you do in that what could you do to mitigate that risk? Well, we worked with these guys and came up with an interesting idea, and we called it falling conductor. It's actually not falling, it's falling conductor. Because a conductor takes so many milliseconds to hit the ground. I think it's 40 milliseconds if you drop it. So if the conductor breaks and it's falling on the ground, you can actually detect it and trick the recloser or breaker before it hits the ground. It was a great idea. We patented it, or SDG&E patented it. We worked with them. They patented the idea. And so they've been using it out and on some of their feeders going through. That was a great project to work on. We've also been working with different companies, you know, to look more at the approach of what they need to do, like PG&E and the CPUC. We're working there. Optimal operational strategies for PSPS. That's the public safety power shutoff. You know, if they have very dry conditions, windy conditions, then they'll de-energize some feeders. There's just a ton of protection and analytics. You see rank the circuits, manage load generation impacts. All this ties together. And that's why I say I think wildfire is a very interesting area technically, right? Because it does tie together so many different aspects and types of expertise. Wildfire mitigation program, design and implementation. You know, we've been working with LUMA to look and go through and kind of assess identify the risk, assess the risk management, review your design standards, processes, system level process, protocols, and rate wildfire risk. So these types of things, again, this is pretty standard as you start figuring out kind of you want to move into this area and figure out how you address this. And another similar project, worked with HECO on a project very similar to the one we've working on with PG&E. Electrification, electrification is definitely going to be, we work with a lot of different companies here on this, looking at roadmaps and how do you roll that out? Where do you need to put charging stations? There's a lot of details, a lot of things here. We've done a lot of work with microgrids, right? So you can see all this to kind of come together. This is a big area. Everyone's obviously more concerned about the fleet electrification because of the larger impact on the grid and what they're doing. So again, there's a lot of activity going on in this space. And then, kind of you could go through a standard process here again to look at it. And all the analytics kind of pull into this, guys. So the bottom level up, you look at your locations, right? Forecast adoption, loads, map and aggregate the facilities. We've actually been working with utilities kind of forecasting the load. And again, I think utilities have been pretty conservative on that. And so I think there's going to be a lot more coming out than we see today. So another example of the utilities we work with for electrification. So, but looking at fleet loads and how would you approach that? I'd already mentioned the fleet loads. How you can go through and look at this, and, how do you size the load? Load's not uniformly distributed. So they were originally trying to look at kind of uniform distributions. It's very site specific. So we can look at the managed charging, if you can manage the charging of the fleet versus just having everything done randomly. Right, and then you look at the profiles and go through. But again, another project here, lots of information, a lot of data, a lot of analysis on how to do that. And I really didn't touch on data centers, guys. I had a slide, but I took it out because I knew I was going to talk for too long. But I do think the data centers, we're working with folks. I mentioned the forecasting and the siting and also starting to look at some of the monitoring aspects of what you can do there. The loads are so large and so impactful to the grid. I think that's going to warrant additional work and effort there. So that was a very quick overview, guys. I apologize for running through the topic so fast. But I really just kind of want to give a flavor overview of what we're seeing in the market on the analytics front. So. Any questions?
Got one over here. Okay.
David, so I'm Daryl. I wanted to introduce myself. I'm one of your partners. We work with Quanta Technologies. We work with Demir and Carl Wilkins.
Oh, yeah.
Yeah, but what I wanted to see if you had an opportunity to talk about is some of the tools that Quanta Technology uses around LVDER. And the reason that is important from a data perspective is as the utilities are really trying to get to zero carbon by 2030 and 2050 as mandated by the PSC, right. There's also this pressure coming from the infrastructure bill and NEVI as it relates to EV and equity as well, and really to figure out how Quanta has created tools around locational value DER to really support the utilities and their whole strategy around NEVI and EV in communities where there's some challenges around equity and where you put EV and how you get to zero carbon by 2030 or 2050 in the communities.
Yeah, no, thank you. And we have done exactly that. I think you saw we've done quite a bit of work in working with people to figure out the siting and the interface and kind of the planning and how you tie it all together. We've created tools with that. Carl's actually driven a lot of that work and a lot of those initiatives on the distribution side. So I think Carl would probably give a much better detailed answer to that than I would, but I know he's done quite an extensive lot of work in that area.
Yeah, and some of the data collection of that is extremely important as the utilities look at what their public-private partnership is going to look like under NEVI and getting the federal funds from the infrastructure bill, using that data to be able to say what their EV infrastructure is going to look like.
Right.
So that's where there's some leverage data points around that as well.
Right.
Hey there. You've shown a lot of examples of showing data analytics for the utilities to use. Have you worked with any utilities on customer-facing dashboards? I mean, a lot of what we're trying to do is educate our users on why rates are what they are, why, and try to educate our users on some of that. Have you seen any analytics that get pushed out over portals to customers on electric usage?
Well, I mean, obviously, all the AMI systems have portals that go out to customers today. So, provide information on usage, and so there's some different rate comparisons and different things you could look at. That's pretty common in the industry today. Was there something beyond that specifically you were thinking, or?
Especially when we're trying to see EV adoption and that sort of thing, is there any kind of tools that they could see? Can my transformer handle it? So, stuff like that I've seen. That what impact would solar panels on my roof versus an EV at my house do for me, and that sort of thing? Is there anything that utilities are creating in that respect?
No, I haven't really seen. That's actually a great thought. But no, I've not seen any kind of tools there. And I think the bigger thing is, most customers are assuming you're going to upgrade the transformer, right? So that's really more of a utility issue. How do you address that, and how do you fix that? That's actually one of the big things about the service transformers in the AMI. And again, that's been around for a while. Don't get me wrong. There's a lot of work been done on the service transformers and AMI and other examples, but 2.0 will offer some vast improvements over what's been done previously. It's going to take a lot of the guesswork out. So I'm sorry, but to answer your question, I think, no, I haven't really seen that type of request from utility, or I'm not aware of it. Carl may be aware of it. Carl Wilkins, another gentleman in our team, but I'm not.
Question for you. What Don's talking about kind of ties in with the AMI 2.0 architecture, but part of that architecture is that third parties should be able to develop applications to run at the meter, on the meter.
Right.
Are you seeing that opening up? Because right now, I think most of the time they're developed, you have to use the SDK of the meter manufacturer. Is that changing? Have you seen,
We just got the SDK. So I do see that kind of opening up to where you can do more applications. Now, I will say, some of the things we talked about, the phase detection and other things, those are really those apps that are coming out with the meters out on the market today. So they've already included some in there. You have the ability to do more in there. And actually, I think that's going to be one of the large things to figure out here now with 2.0 as we take the next step is, how do we leverage that, and what do we want to leverage? There's some things there like interface to home, the solar panels on the homes and other things they talk about for control. I'm a little skeptical there, just because when we did the first round of meters and we were trying in-home thermostats and other things, you run into all sorts of propagation issues that aren't easy to solve, right? So that's just me personally. That doesn't mean they haven't overcome it somehow. Personally, a little bit of skeptic there, but I think there are other areas we really do need to look at and see, how we can leverage that type of technology.